Have you ever wondered why, when you jump, you don't float off into space? You leap, you ascend, and then you descend, your feet fastened back to the solid earth underneath. It's a routine scenario, something that we usually take for granted. But have you ever paused to ponder on this seemingly simple act? A little reflection on this could take you on a voyage through one of the most fundamental aspects of our universe. Or take the case of an apple falling from a tree. It does not hover in midair, nor does it ascend towards the sky. It falls, as if it is being pulled by an unseen hand, straight to the ground below. The apple, suspended on the tree, once it detaches, obeys a command that seems inborn, the very fabric of reality. It drops without hesitation or delay, following an invisible and unerring path straight downwards. This force, this unseen, omnipresent commander that directs the motion of not just apples, but everything from the most minute particles to the grandest celestial bodies, is something we experience every day. However, despite its unending presence and undeniable influence, we rarely spare much thought for it, engrossed as we are in our daily lives. The answer to this is an invisible force that we experience every day, but perhaps don't give much thought to: gravity. Gravity is essentially the force that attracts two objects towards each other. You may not realize it, but it's a fundamental aspect of our everyday lives here on Earth. Consider this for a moment. Every item in your vicinity, regardless of its size, is exerting a slight gravitational pull on its surroundings. Seemingly insignificant items such as the pen on your desk, the cup of coffee next to you, or the phone in your hand, they all possess a gravitational force. However, due to their minute mass compared to colossal entities like Earth, the effect of their gravitational pull is essentially negligible to our perceptions. This invisible yet powerful force affects not only our planet but also permeates throughout the cosmos. From the tiniest particles to the most massive celestial bodies, everything is under influence of gravitational force. The stars in the sky, the planets in our solar system, galaxies far away from us, they all are exerting and experiencing gravitational forces. The moon orbits the Earth orbits the sun, and even galaxies are bound together in clusters, all because of this unseen force we call gravity. It shapes the cosmos, governs the movements of celestial bodies, and even dictates the course of light itself. So, the next time you sit down, just remember that the chair you're sitting on, the screen you're looking at right now, all of these things are pulling on each other with the force of gravity. However, the strength of this force depends on two things: the mass of the objects and the distance between them. This means that how heavy or light a certain item is, and how far or close it is in relation to another, directly influences the strength of the gravitational force acting upon it. Let's consider this further. When mass, we're referring to the measure of the amount of matter in an object. A simple example would be a feather versus a bowling ball. The bowling ball has much more mass than the feather, therefore it has a stronger gravitational pull. On the other hand, distance means the physical space between two objects. The closer the objects are to each other, the stronger their gravitational pull. The farther apart they are, the weaker the gravitational pull. Think of two magnets. They are close together. It's hard to pull them apart because of the strong attraction. But the further you move them away from each other, the less they attract. That's why the Earth, being a massive entity compared to us humans, exerts a considerable gravitational pull, causing us to be drawn towards it. This is the reason we don't float off into space. It's an immense force that we're constantly subjected to, yet we adapt so well that we don't even notice it. And this is the reason we don't feel the gravitational pull of minuscule objects like a feather. These objects do exert gravity, but their mass is so small, and their distance from us is so close, that the force they generate is negligible to our senses. So, in essence, the larger the mass of an object, and the closer it is to another object, the stronger the gravitational force between them. Conversely, the smaller the mass and the farther away the objects are, the weaker the gravitational pull. This is the core principle upon which the concept of gravity operates. It's also why we don't feel the gravitational pull of a tiny pebble or a feather. At the same time, the further away two objects are from each other, the weaker the gravitational force between them. This is an interesting phenomenon that is integral to our understanding of the universe, and it has far-reaching implications in various fields like physics, astronomy, and even engineering. Consider this. The crux of this idea lies in the distance between two objects. As the gap between these objects increases, the gravitational pull between them decreases. This concept, while seemingly simple, is rich with complexity, contributing to the grand tapestry of physical laws that govern our universe. It's not just a theory either. In practice, We see this principle at work continuously in our life. The tides ebbing and flowing under the moon's influence, apples falling from trees, every step we take, all of these are testament to the relentless tug of gravity. Now let's delve a bit deeper. What happens when we move far away from Earth? Here, the concept of gravity becomes even more fascinating. Imagine our astronauts floating in the vast expanse of space, miles away from the gravitational pull of our home planet. The effect is quite dramatic. In space, the gravitational force between an astronaut and the Earth significantly is less due to the increased distance. This decrease in gravitational force means that astronauts, who are much further from the Earth's center than we are, experience something remarkable, a sensation that we Earthbound folks refer to as weightlessness. But gravity doesn't just keep us grounded. This profound force, a staple of our existence, works tirelessly, never pausing for even a moment. It's omnipresent, underpinning the very fabric of our universe. It's the unsung hero, persistently maintaining the delicate balance of our cosmos. This force isn't in its ubiquity, it's also responsible for celestial mechanics, the grand waltz of the solar system. It's gravity that keeps the Earth, our home, in its rhythmic dance around the sun, year after year, without fail. This invisible tether, this cosmic leash, prevents us from wandering off into the cold, dark abyss of space. And it's not just the Earth that's kept in check. The moon, too, our silvery companion in the night sky, is held in its orbit around us. This gravitational bond between Earth and moon is so strong, it survived billions of years of cosmic evolution, resisting the chaotic nature of the universe. Gravity also plays a pivotal role in shaping the very face of our planet. The ebb and flow of tides that we witness daily is a consequence of gravity's tug. This unending dance of sea levels, in perfect sync with the moon's orbit, is an ode to gravity's influence. In the grand scheme of things, gravity is a cosmic sculptor, an unseen artist. It's the reason why planets, stars, galaxies, and even the universe itself has its shape. It molds celestial bodies, turning dust into magnificent galaxies. It forms stars, the nuclear furnaces that light up the universe. It creates planets, the cradles of life, and gives them their spherical shape. In essence, gravity is the great cosmic choreographer, dictating the delicate dance of celestial bodies, the undulation of the oceans, and the structure of the universe itself. But gravity doesn't just keep us grounded. It's the very reason the universe is the way it is. It's the reason the tides ebb and flow, and why planets, stars, galaxies, and even the universe itself has its shape. So, to summarize, gravity is a force of attraction that exists between any two masses, any two bodies, any two particles. Gravity is a fundamental phenomenon observed in all physical objects in the universe, from the smallest particles to the largest celestial bodies. It's the mechanism that governs the movement of stars, galaxies, and interstellar objects. Considered as one of the four fundamental forces of nature, gravity plays an indispensable role in the structure and dynamics of the cosmos. It's the reason why planets follow elliptical orbits, why stars cluster together forming galaxies, and why these galaxies themselves form clusters, creating the intricate cosmic web that we observe in the universe. On Earth, we experience gravity as a downward force that keeps us firmly planted on the ground. This downward force is the Earth's gravitational pull acting on our bodies. It's the same force that makes an apple fall from a tree to the ground. It's an invisible, yet ubiquitous force that how we perceive and interact with our environment. Gravity is also responsible for the tides in our oceans. The gravitational pull of the moon creates a bulge in the Earth's oceans, causing high and low tides. Moreover, gravity is an important factor in space exploration. It determines the trajectory of rocket launches and space probes. In essence, gravity is an all-encompassing force of attraction that influences how matter interacts in the universe. It's a force that depends on mass and distance. The more massive an object or the closer it is, the stronger the gravitational pull. Gravity is an unseen, mysterious force that we can't visualize, yet its influence is undoubtedly felt in our everyday lives. It's the invisible power that keeps our feet firmly planted on the ground, preventing us from drifting off into the boundless expanse of the cosmos. It's the reason why, when we jump, we always come back down. It's the force that tames the chaos of the universe, maintaining a semblance of order and harmony. It's fascinating to think about how gravity affects practically everything around us. When you toss a ball into the air, it's gravity that brings it back down. When you pour a cup of coffee, it's gravity that prevents the liquid from floating away. It's the reason why mountains can't grow infinitely high and why rain falls down from the sky. In the grand scale of the cosmos, gravity is the glue that holds galaxies together, preventing stars and planets from wandering off into the dark void. It's that keeps the moon in orbit around the Earth and the Earth in its course around the sun. It's the cosmic ballet orchestrated by gravity. When considering gravity, one can't help but think of the iconic image of an apple falling from a tree. This very phenomenon set the stage for Isaac Newton's revolutionary principles of motion. It's no understatement to say gravity has shaped our understanding of the universe. So next time you take a leap or observe an apple descending from a tree, remember, it's all thanks to gravity. As we continue on our journey to understand gravity, let's recap our learnings. Gravity is not just a concept, it's an invisible force that governs every aspect of our lives. It's the reason you're not floating off your chair, and why objects fall. It's force keeping the Earth and stars in their places. The strength of gravity is influenced by two factors: the mass of the objects and the distance between them. Heavier objects and closer distances result in gravitational pull. This principle keeps us grounded and the Earth orbiting the Sun. Gravity also maintains the orderliness of the universe. It's what keeps celestial bodies in their respective orbits, maintaining the universe's beautiful orderliness. So next time you gaze at the night sky or drop a pen, remember gravity. This unseen force constantly at work is the unsung hero that governs our universe. Thank you for watching. Please like and subscribe the video.